In studio with us right now, we have Matt, and I don't want to just call you Earthquake Matt. So where do you work, Matt?
I work at Cal State Bakersfield. I'm a professor in the Department of Geological Sciences, and you can call me Earthquake Matt because I study earthquakes.
Matt, there we go. All right, so easy enough then. All right, so how long have you been at the university?
I got here in fall 2020, so right in the middle of the pandemic. I moved here from the Netherlands, so it was a long trip, and I've been here 4 years now.
And in the Netherlands, were you doing anything similar to what you're doing at the university?
Very similar. I was in my postdoc, and so I was learning to make computers do earthquake cycle modeling.
Okay, and the classes that kids would be taking to learn about this would be?
Yeah, so I teach geophysics. So that's a class for majors. I teach a course in plate tectonics. That's for upper division students and grad students. And also, one of my favorite classes to teach is natural disasters. And that's a GE course, a general education course at CSUB.
And what would that satisfy for kids?
That satisfies a science requirement, and so I like to, make sure we cover a wide range of hazards. I always start with earthquakes because I love them, but we've been having hurricanes recently in the East Coast, so I've been using that as my examples.
So you love earthquakes?
I do.
Not experiencing them, but you love studying them.
Exactly.
Well, maybe you like experience, but I mean, that way you get a lot of data, right?
Exactly.
Okay. Well, go ahead. I'm sorry.
Yeah, so actually, until I came to California, I always studied earthquakes from where they don't happen. So now I'm in California. There's a little bit of fear here now living.
So you've been here for 4 years now.
Yes.
And how many earthquakes have you experienced where you're at the place?
Yeah, I've only ever experienced one earthquake, and it wasn't even in California. It was an earthquake that occurred in Virginia, and I felt the shaking up in Pennsylvania.
Oh, okay. So you weren't here during, I think it was during the summertime. We had a little bit of activity here.
I was gone for 48 hours in Pennsylvania, and I missed it.
And that's when well, you know what? The guy from New York didn't miss it because when it happened,
yeah.
I was full alert when that thing happened.
Yes.
And the first time it happened was years before that, but I had no idea what to expect,
yeah.
Going through that for the first
yeah.
time. So when we have an earthquake, what is happening underneath the earth? Because we don't see what's happening, like when you can see a hurricane and other natural disasters. Earthquakes, we don't see.
Yeah, that's exactly right. Earthquakes are basically, in the earth, we have cracks between blocks of rocks. And an earthquake is just when that crack all of a sudden decides to slip. The two blocks slip past each other. It happens very quickly, abruptly, after years, decades, hundreds of years of slowly trying to move and not being able to. And then all of a sudden, in a couple of seconds, everything slips. Now, what's interesting is we actually do see earthquakes at the surface. So, for example, we know about the San Andreas Fault here in California, and we can see the last earthquakes on the San Andreas Fault did break up to the surface, and we can study that surface break to say what happened in those historic events.
So, talking about slip, because there was somebody, I forget where I was reading this, but somebody was saying that, I don't remember the number of years, but at some point, Los Angeles will be north of San Francisco.
Yes. So, on average, the San Andreas Fault divides the Pacific Plate from North America, and they move at about 40 millimeters a year or a couple inches per year. So you can, do that.
It won't be around, but
you can do that calculation. It'll take millions of years, but eventually Los Angeles, which is on the Pacific Plate, will work its way up north to be on next to San Francisco, which is on the North American plate.
Okay, and have you worked a lot with the Ring of Fire?
I do, yes. So we are actually part of the Ring of Fire, being on the Pacific Ocean. We have our earthquakes, but we don't have the volcanoes, which is where the fire comes from. But I do study what are called subduction zones, and they have the biggest earthquakes, they produce the biggest tsunamis, and that's where we have the biggest volcanoes. And I've studied subduction zones for about 10 years now.
Okay, so I'm sure a lot of kids are looking at this going, all right, what have you got here? So
yeah.
What are we going to be doing?
This is a seismometer. This is what we study earthquakes with. Now, we use actually a lot of tools to study earthquakes, but this is one of our main ones. And so in here, we've got a little device that simply measures the motion of the ground. Okay? And so these wiggly lines you can see on the computer here, in fact, it's probably every time I tap this table, will measure the table moving. Okay? And so if we see a big signal, that tells us either the earthquake's really big, or it's really close, or both. And if we have a lot of these seismometers, and in California we actually have thousands of these instruments all distributed around the state, We can locate earthquakes, say where they happen to a really high degree of precision. We can say how big the earthquakes are, their magnitudes, and we can tell what type of faults they happened on.
So that brings me to my next point. Are there instruments that can help detect before, and I know it's going to be a very short amount of time, that it would alert you that, oh yeah, this is going to happen, and then a couple seconds later, bam, it's happening?
Yeah. The pipe dream, of course, would be to say an earthquake is happening tomorrow or next week.
Right.
We know that's not going to happen. This is a very complicated problem, and it's unlikely to happen. But when an earthquake happens, it produces a number of different seismic waves, fast, smaller P waves, larger, more damaging surface waves. And the P waves, if we can detect them ahead of time and say the earthquake is a magnitude 6 or a magnitude 7, we can warn people even before the S waves or the surface waves get to shaking. And that usually can give people about maybe 5 to 10 seconds of warning in a good scenario.
But at least you get yourself in a different situation to get yourself a little safer for when that does happen.
Exactly. This is the basis of the shake alert system, which is widely
coming up.
available. Yeah.
And I know because the school's going to be doing that, I don't know, I would imagine it's a statewide thing.
The Great Shakeout, yes.
Right.
So California is very good at earthquake education, and we also have systems on our cell phones, and you can download an app, and if you're set up for the emergency alerts, you will get a shake alert during a big earthquake. So,
right, because I remember I got one on my phone,
Yeah.
and I'm like, well, geez, no kidding, it didn't happen because I just felt it, right?
yeah. This, of course, is the problem, is that if the earthquake is close to you, those P waves and the strong shaking get to you at the same time. That was one of the activities I did in the first week of class in my natural disasters class. We calculated how much time it would take for the shaking to get there. 7 seconds. That's also the same amount of time it took the computers to figure out there was a big earthquake.
Right.
Okay, so that didn't help us very much here.
So taking a look at the screen again, when you have some vibrations on here, so we can see, so what are the 3 different lines?
Yeah, so the 3 different lines represent the directions this table can move in 3 dimensions. So the blue line on top here, this represents the up and down motion of the table. The yellow line represents the motion of the table towards and away from me, and the pink line represents the motion of the table side to side.
Okay, so if we got this thing really going, so now we can see it coming through there.
Exactly. So you made your own earthquake on the table.
Yeah, well, we'll avoid those. So if somebody wanted to study this, and they're in high school right now, what are some things they need to get themselves geared for because they're like, hey, this sounds interesting, and I might want to get into this?
Yeah, it's really important to have a strong quantitative background. Math, physics, they really, really are important for understanding earthquakes. So when I was a high schooler, I was taking courses in algebra and geometry, then I was in pre-calculus and calculus, so, and I use those every day. My students don't believe me that I use all these tools every single day. I was writing something on the board and they said, how did you know that? It was something about the statistics I used to study earthquakes. And, you know, I literally do it every week, so it's second
Something that
nature
you
to me.
use, right? And
Yeah.
I mean, if you use it, it'll be second nature and
Exactly.
you're used to it.
Exactly.
All right. So once again, Earthquake Matt,
Thank you so
you
much.
for coming in. That was certainly informative, and hopefully you're in California next time we have one. That way you can feel it and feel a little better with that.
Yeah. Thank you.
All right. Hey, you know what? We'll be back with more right after this.